Good morning students, welcome back to the session. Today in this video I am going to start chapter 6. I have completed 5 chapters. Before going to start this chapter, I will ask you a few questions. What is matter? Matter has mass and it occupies space. And matter exists in 3 different forms. What are the solids, liquids and gases. See, in our surroundings there are so many objects. So all these exist in these three different, either solid, liquid or gases. In all these matters, it contains smallest particles, or this matter contains smallest particles. So that smallest particles are known as atoms. What are atoms? Atoms are the smallest particles that you cannot further divide and you cannot see with your naked eye. That smallest particle is known as atoms. For example, if you take a wood, small piece of wood and make it a powder, you will get a particle, single particle. In that powder you can find out a particle. So that particle that you can by using the microscope or something, further you can divide it. So until you can further divide it into the smallest particle, finally you will get a very tiny small particle that you cannot divide again. That much small particle is known as atom. And I will give one more example. For example, if you take our hair, it is very thin. If you take one hair, it is very thin, and the size of this hair, when you compare with the atom, it is 500 times bigger in size. It is, when you compare, means that atom is very small, we cannot see through our naked eye. So our tiny hair is 500 times bigger in the size, in the thickness, not in the length. So that much small particle is known as atoms. And if you take any kind of matter, these atoms are present. Due to the combination of these atoms, we can get different kinds of matter. And in these atoms, there are two types of charged particles are present. If you take any kind of matter, in all the matters, in atoms, there are two types of particles are present. They are electron and protons. You take any kind of atom, any kind of matter, in that atoms are present, and that atoms contains these two types of charge. Electrons have negative charge and the protons have positive charge. And along with these two charged particle, one more particle also it is present in an atom, and this particle has no charge. So these three particles are present in an atom. Due to this, these three particles are known as subatomic particles of an atom. So one more question. What are the subatomic particles of an atom? Electron, proton and neutron. And the mass of an atom, coming to an atom, the mass of an atom is due to the mass of protons. Mass of protons. And these protons, how these subatomic particles are arranged in an atom. For example, if you take an atom is in spherical shape, and the mass of an atom is due to the charge of neutrons, and mainly the mass of an atom is concentrated at the center of an atom. So this is the center of an atom. So the mass, the entire mass of an atom, this is an atom. The entire mass of an atom is concentrated in the center of the atom, and this is known as nucleus. It is known as nucleus. And in this, there are two types of particles are present. One is the positive charged particle, that we'll call it as protons. Along with the protons, neutral charged particles, that neutrons also present. Neutrons also present. So if you take an atom at the center, it contains protons and neutrons. Protons and neutrons. And what about electrons? These electrons are arranged in the different orbits around the nucleus of an atom. So in different orbits, these electrons are arranged. So electrons are having negative charge, protons are having positive charge. And who discovered these subatomic particles? See, in 9th class, you learned about what is an atom and what are the subatomic particles of an atom, and how does these particles, subatomic particles, are arranged in an atom by different scientists. They propose different theories. J.J. Thomson, Rutherford, like different theories you have. So from all these theories, from all the theories, they said about the center of the atom, it contains protons and neutrons, and the electrons are revolved around the nucleus in different orbits. And who discovered this subatomic particle? Electrons are discovered by J.J. Thomson, and protons are discovered by Chadwick, James Chadwick, and neutrons are discovered by Goldstein. Sorry, I said wrong. Electrons are discovered by J.J. Thomson, and protons were discovered by Goldstein, and neutrons were discovered by James Chadwick. And this is about the atom. Now we will discuss at the present in this video, we will discuss more about atom, the structure of atom. You know about the basic information. What is an atom? What are the subatomic particles? How these particles are arranged? Now, if you discuss different elements, atoms of different elements. First, what is an element? It is the pure form of the substance that you cannot divide. This is a pure form that you cannot split or break down into further either by chemical reactions, by any chemical reactions. Such purest form of substance is known as element. If you take any element, almost nowadays scientists, they discovered 120 elements, 118, almost 120 elements. In all the elements, suppose if you take, we have hydrogen, helium, lithium, beryllium, boron, like that we have 120, almost 120 elements. So in all these elements, if you take for example of hydrogen, in this hydrogen element, is it contain the same kind of atom? And one more element, carbon, is there. In that carbon, see, if you in 120 elements, in all the elements, the atoms are have same kind of atoms are present in each element or not. So at the present topic, we have to discuss more about structure of atom. So today topic is structure of atom. Today I am going to learn about structure of atom. In this topic, we have to learn about all the atoms have the same subatomic particles. All the atoms, we have hydrogen atom, carbon atom, lithium atom, boron atom. So different elements will have the same kind of atoms. So the atom of hydrogen and the atom of carbon will have the same kind of subatomic particles or not. Next, why atom of one element form the atoms of other element? Why is atom of one element from the atom of other element? Next, how are the electrons distributed in the space of an atom? For example, if you take hydrogen and if you take oxygen, in these elements, atoms of these elements, the number of electrons in each atom is different. So how does these electrons are arranged in each atom of an element? That points we have to discuss in structure of atom. So before going to discuss this structure of atom, first we have to learn to understand about the structure of atom. We have to learn about the wave nature of light and different colored flames and their characteristics. If you learn this, then you can understand the structure of atoms. So first we have to start with the nature of light. Wave nature of light. Already in 8th class, in sound lesson, a vibrating body produces a sound, and this sound has energy, and the sound energy travels in the form of waves. Like sound energy, this light energy also travels in the form of waves. If a disturbance is created in any medium, either light or sound in any medium, the disturbance is carried out in the form of waves. So if you take in the light waves are traveled, the light waves contains two type of waves, electric and magnetic waves. Sound has one type of waves, but if we come to the light, it contains two types of waves, electric waves, electric field and magnetic field, or otherwise electric wave and magnetic wave. These two waves are perpendicular to each other, like this. Electric wave travels like this, magnetic waves travels like this. So these two travels are connected perpendicular to each other, and these two travels are travel along with the form of waves. These two are connected with the light wave, and these two will travel along with the they travel in perpendicular direction. Here I am showing this diagram. This is the direction of electric wave, light wave. This is known as light wave, and this light wave is also known as electromagnetic wave. This is also known as electromagnetic wave. From sun we can get the light. So out of that light you can see a part of it only. So what part you can see, that you can call it as visible light. So visible light above and below, there are different kinds of light frequencies are there that we cannot see. Our eye is not supposed to see all those above and below frequencies. So which part we can see, which is visible to our eye, is known as visible light. So that now from that light above, below and visible light, all these, they are traveling in the form of waves by electric waves. This blue represents electric field or electric wave, and this black represents the magnetic magnetic waves or magnetic field. So these two waves are perpendicular to each other, and they are traveling along with this wave. So this diagram is very, very important for 2 marks or 1 mark. So many times they ask to draw the wave, electromagnetic wave. So here in your textbook you have the figure like this. So after drawing this figure, you have to represent the directions, which is magnetic wave, which is the electric wave, and what is the direction of the wave. So you must represent by this arrow marks. So this is very important in diagrams. So I said wave means the disturbance is carried out. Now if you take in light, how does the disturbance is created? First, an electric charge creates a disturbance in the electric field. First, an electric charge creates a disturbance in the electric field. And again this electric field creates a disturbance in the magnetic field. So due to that, electric field vibrates and the magnetic field vibrates, and these two vibrations travel in the form of waves along in the perpendicular direction. Now what is the velocity of light? See, for the propagation of a sound, it requires a material medium. But for the light waves, it does not require any material medium. Light travels in the vacuum, and in vacuum it is very fast. The speed of light in vacuum is 3 into the speed of light in vacuum is 3 into 10 to the power of 8 meters per second. 3 into 10 to the power of 8 meters per second. Okay, this is about electromagnetic wave or about light. And any wave, mainly it has two characteristics. Any whether it is a sound wave or heat wave or tidal wave, any type of light, any type of wave, it has mainly two characteristics. They are it has the characteristics of wavelength and frequency. It has wavelength and frequency. What is wavelength and what is frequency? For example, I will draw two waves. Now you see two waves, 1 and 2. The distance between one peak to the other peak is known as wavelength. It is known as wavelength. See, this is the peak points. Either you can take top or bottom. From the distance between from this peak to this peak is known as wavelength. And the wavelength of a wave, it is represented by the letter lambda. Here I wrote wavelength, it is represented by the letter lambda. Wavelength of a wave, it is represented by the letter lambda. And frequency, any wave you take, the distance between any two peaks, the distance between these two peaks is represented by the letter lambda. So lambda represents wavelength. Now one more thing is frequency. Within a given time, generally we will take it the time in seconds. Within the given time 1 second, from a given point, the number of wave peaks are covered. How many number of wave peaks are traveling within the given time from a given point is known as frequency. Here I will count the frequency of these two waves. So from the given point within the given time, 1, 2, 3, 4, 5, 6, 7. Here 7 peaks are traveled in 1 second. Now if you take this, only 1 and 2 only. So within the given time, the number of wave peaks are passed through a given point is known as frequency. So here the frequency of the first wave is 7 and the frequency of the second wave is 2. And the frequency is always represented by the letter mu. Frequency is always represented by the letter mu. Once again, wavelength it is represented with the letter lambda and frequency it is represented by the letter mu, and this mu is nothing but the inverse of wavelength. Once I will write on the board. There is a relation between frequency and wavelength. There is a relation between wavelength and frequency. So what is the relation between this wavelength and frequency? Wavelength it is represented by the lambda and frequency it is represented by the letter mu, or otherwise you can write like this. So these two are inversely proportional. For example, if you take a lambda, these two are inversely proportional. In this example, we have discussed this point. See, here wavelength is less and the frequency is more. 1, 2, 3, 4, 5, 6, 7. And here you see wavelength is more and the frequency is less. Here wavelength is less and frequency is more. And here you see wavelength is more and frequency is less. So there is a relation between wavelength and frequency, And when you remove this proportionality constant, you have to represent with a constant that you have to take for the light wave as a C. That we can represent with the letter C. So C is equals to, or otherwise lambda is equals to C into 1 by mu. So when you take C, do cross multiplication, you will get lambda into mu. This is very important relation. This applicable for any wave, whether it is a sound wave, light wave, any type of wave. So here C represent the speed of light in vacuum, that you can get the product of lambda into mu. So if you want to find out the speed of sound wave, so apply this, the product of lambda and frequency, then you can get the speed of sound. So this is applicable for any wave, any kind of waves. Next, one more point. Coming to the electromagnetic wave. This electromagnetic wave, that in that we can see a part of it, that we'll call it as visible light. We'll call it as visible light. In this visible light, you can see 7 colors. What are that? VIBGYOR, VIBGYOR. Violet, indigo, blue, green, yellow, orange and red color. So all these colors have different frequencies, the intensities and different wavelengths and different frequencies. All these colors will have the different frequencies and different wavelength, and the intensity of these colors differ from one color to the other. See, you can see violet, the intensity of violet is completely different from the red color, and the violet and red, if you take starting and ending, red has less frequency. I will see the textbook and I will tell you. Violet has shorter wavelength. Shorter wavelength means you can represent with this, and it has a longer wavelength. So by the shorter wavelength and longer wavelength means what? Shorter means if the wavelength is shorter, frequency is more. Wavelength is shorter means frequency is more, and red has longer wavelength. Wavelength is longer. If wavelength is longer, frequency is less. So the entire range of all these wavelengths are known as electromagnetic spectrum. Along with the visible light, or otherwise if you take the visible light, all these frequencies are known as visible spectrum. And in next video we have to discuss about what is electromagnetic spectrum. Thank you.